Okay, so today we're going deep on something that's, well, it's kind of become the backbone of how a lot of the modern web works. Kubernetes.
Yeah, it's one of those things you might have heard of, especially if you're, in the tech world at all. But even if you're not, even if you're just like someone who uses apps and websites and kind of wonders how it all works behind the scenes, like how do these things scale to millions of users? How do they, update seamlessly without us even noticing? That's where Kubernetes comes in.
Yeah, it's really like, if you think of the internet as this giant city, Kubernetes is like the underlying infrastructure. It's the roads, the power grid, the plumbing, all the stuff that has to work perfectly for everything else to function.
Exactly. And we've got some really interesting stuff to dive into today. We're going to be pulling from a bunch of sources that break down the core concepts of Kubernetes, look at how it's actually architected, and there's even this really neat analogy to the human body, which, trust me, it makes a lot of sense when you see it.
So let's start with the basics. What exactly is Kubernetes?
So, in a nutshell, Kubernetes is what's called a container orchestration platform, and it's open source, which is a big deal. Now, to understand what that means, we've got to talk about containers first. You can think of a container, like imagine a Docker container as this little package that has everything an application needs to run the code, the libraries, all the dependencies, all bundled together.
So it's like a self-contained unit.
Exactly. It's self-contained. And the beauty of that is it can run on any machine that has a container runtime environment, like Docker, without having to worry about compatibility issues. But now imagine you have like hundreds or even thousands of these containers running different parts of your application. It becomes a nightmare to manage, right? How do you deploy them? How do you make sure they're running? How do you scale them up or down based on demand?
Yeah, that sounds like a logistical headache.
That's where Kubernetes comes in. It's like the conductor of an orchestra, making sure all these containers are playing in harmony. It automates all those tasks I mentioned, deploying containers, scaling them, making sure they're healthy, and a whole lot more.
So it brings order to the chaos.
It does. It brings order to the chaos of managing containers at scale. And the history of Kubernetes is actually pretty interesting. It was initially developed by Google based on their internal system called Borg. So Borg was this super secret internal Google project they used to manage their own massive infrastructure.
Oh, wow. So they had like this internal secret sauce and then decided to share it with the world.
Yeah, pretty much. They open sourced it back in 2014 and it, took off like a rocket. And that's partly because it was battle tested. I mean, Google was already using it to run like everything. Search, Gmail, YouTube, all of it. So people knew it could handle serious workloads.
So it was like a proven solution from day one.
Exactly. And it was also designed from the ground up to be cloud native. Cloud computing was already becoming the dominant model, so Kubernetes was right there at the forefront.
Now, we mentioned Docker earlier. What's the relationship between Kubernetes and Docker?
So initially, Kubernetes was very closely tied to Docker. Docker was kind of the default container runtime that everyone was using. But then Kubernetes introduced this thing called the Container Runtime Interface, or CRI.
CRI, what is that?
So CRI basically created this abstraction layer between Kubernetes and the underlying container runtime. What that meant is Kubernetes could now work with any container runtime that implemented the CRI, not just Docker.
So it opened things up.
Yeah. And later on, Kubernetes actually made a big decision. They deprecated direct Docker support.
They got rid of Docker support.
Not entirely. It's more like they stopped relying on Docker directly. They shifted to these other CRI-compliant runtimes, like containered in CRI. These runtimes are, in some ways, simpler, more focused on just running containers. And this shift actually reflected a broader move in the industry toward open standards. There's this thing called the Open Container Initiative, OCI, which is all about standardizing container formats and runtimes.
So it's about creating this ecosystem where different tools can play nicely together.
Exactly. It's about interoperability, portability, all that good stuff. So you're no longer locked into a single vendor or technology. You can choose the container runtime that works best for you, and it'll still work seamlessly with Kubernetes. And with this huge open source community constantly contributing to it, Kubernetes is always evolving, adding new features, improving performance, getting more and more robust.
This is like constantly getting better.
Absolutely. It's a living, breathing project.
Okay, so we've talked about what Kubernetes is, where it came from. Let's talk about why it's so important. Why do we even need Kubernetes? What problems is it solving?
So to understand that, I think it helps to take a step back and think about how we used to deploy applications before containers and Kubernetes came along. Back in the day, you'd have these physical servers, and you'd deploy your application directly onto those servers.
Like one server per application.
Yeah, pretty much. And that was, it was fine for a while, but it had a lot of limitations. Like, what if your application needed more resources? You'd have to buy a whole new server. And what if one server failed? Your application would go down.
So it's very inefficient and prone to downtime.
Exactly. And then along came virtual machines, VMs. With VMs, you could run multiple applications on a single physical server, each in its own little isolated environment.
So that was a big improvement.
It was, but VMs still had their own overhead. Each VM needed its own operating system, which took up resources and made them slower to boot up.
And then containers came along.
Right. Containers were a game changer because they were much more lightweight than VMs. They shared the host operating system kernel, so they were faster, more efficient, and took up less space.
But then managing all those containers became the new challenge.
Exactly. And that's where Kubernetes really shines. Kubernetes solves the problems of managing containers at scale. It does things like resource optimization, making sure that containers are placed on the right servers to maximize resource utilization, high availability, making sure that your application stays up even if a server fails by automatically restarting containers on other servers, automatic scaling your application up or down based on demand to handle traffic spikes or save resources, and declarative configuration, defining the desired state of your application in simple configuration files and letting Kubernetes take care of making sure that state is always maintained.
And you mentioned earlier that this was all happening around the same time, that there was this shift toward microservices.
Yeah, that's a key piece of the puzzle. So before microservices, most applications were built as these monolithic, single giant code bases. And deploying those monoliths was a big, scary event. You'd have to stop everything, update the whole thing, hope nothing broke.
All hands on deck. Fingers crossed.
Right. But with microservices, you break your application down into these smaller, independent services that can be developed and deployed independently.
So each service is like its own little mini application.
Exactly. And that makes things much more flexible and scalable. You can update one service without affecting the others. You can scale individual services based on their specific needs, but it also creates a new set of challenges. Now you have dozens or even hundreds of these little services that need to communicate with each other, and you need to manage them all.
So it's like you solved one problem but created another.
Right. And that's where Kubernetes comes in again. Kubernetes is the perfect platform for running microservices. It provides all the tools you need to manage those services, to connect them together, to make sure they're running smoothly.
Okay, so we've got the what and the why of Kubernetes down. Let's dive into the how. Can you give us an overview of the architecture of Kubernetes?
Sure. So the basic building block of Kubernetes is a cluster.
A cluster, what does that mean?
A cluster is just a group of machines that are working together to run your applications. You can think of it as a single logical unit, and within a cluster you have two main components, the control plane and the worker nodes.
Okay, so break those down for me. What do each of those do?
The control plane is like the brain of the cluster.
Yeah.
It's responsible for making all the decisions about where to run containers, how to scale them, how to handle failures, and all that good stuff. The worker nodes are the machines that actually run your containers.
So the control plane is like the manager and the worker nodes are the workers.
Exactly. And we came across this really cool analogy that explains it really well. Think of Kubernetes as the human body. The cluster as a whole is the body. And Kubernetes itself, the system that manages everything, is like the central nervous system, the CNS.
So I like that. So Kubernetes is like the nervous system, sending signals and coordinating everything.
Right. And the control plane, as we said, is like the brain. It's responsible for making all the decisions. And within the control plane, you have several key components. There's the API server, which is like the main communication channel for the brain. It's how users and other components interact with Kubernetes.
So it's like the nervous system sending and receiving signals.
Yeah, exactly. Then there's et cetera. It's pronounced et cetera.
Et cetera. Got it. What does that do?
Et cetera is like the brain's memory. It's a distributed key value store that holds all the data about the cluster, the configuration, the state of all the objects, everything. So you can think of it as the brain's long-term memory, storing everything it needs to know.
So it's like the brain's hard drive.
Exactly. It's where everything is stored. Then there's the scheduler. The scheduler is the part of the brain that decides where to run each container. When a new pod needs to be scheduled, the scheduler looks at all the available nodes and figures out which one has the resources and meets the requirements.
So it's like the brain deciding which muscle to use to lift something.
Yeah, that's a good way to think about it. And finally, there's the controller manager. The controller manager is like the body's homeostatic mechanisms. It makes sure that the cluster is always in the desired state. If you define that you want 3 replicas of a certain pod running, the controller manager will make sure that always happens. If one pod fails, it'll start a new one.
So it keeps everything in balance.
Exactly. It keeps everything running smoothly.
Okay, so that's the control plane. What about the worker nodes? What are they like in our body analogy?
The worker nodes are like the body's organs and muscles. They're the ones that actually do the work. And on each worker node, you have a few key components. There's the kubelet, which is like the organ function monitor. It makes sure that the pods on that node are running correctly and reports back to the control plane.
So it's like the brain checking in to make sure the heart is beating properly.
Right. Then you have the container runtime. This is the software that actually runs the containers. We mentioned Docker earlier, but there are other runtimes like Containered and CRIO. These are like the cells and enzymes in our body, the ones that actually carry out the functions.
And we also talked about the kube proxy earlier. What's that doing on the worker node?
The kube proxy is like the circulatory system. It manages the network traffic within the cluster, making sure that requests get routed to the right pods.
So it's like the blood vessels, carrying information and resources around the body.
Exactly.
This body analogy is really helpful. It's making a lot of sense. So we've got the control center, the workers. Now, what about the things that actually get deployed on Kubernetes? What are the building blocks?
So the basic unit of deployment in Kubernetes is a pod.
A pod.
Yeah. A pod is like a single cell in our body. It can contain one or more containers that are tightly coupled and share resources.
So just like different types of cells have different functions, different
Mhm.
pods for in different parts of our application.
Exactly. You might have a pod for your web server, a pod for your database, and so on. And then you have higher level objects that manage those pods. The most common one is a deployment.
Okay, what's a deployment?
A deployment is like cell regeneration. It makes sure that you always have the desired number of replicas of your pod running. So if you define that you want 3 instances of your web server running, the deployment will make sure that always happens. If one instance fails, it'll start a new one. And it can also handle rolling updates, so you can update your application without any downtime.
So it's like the body constantly replacing old cells with new ones, keeping everything running smoothly. And what about replica sets and services? How do they fit into this?
Yeah, so a replica set is sort of the underlying mechanism that deployments use to maintain that desired number of pod replicas. It's a bit lower level, but deployments build on top of them. Now, services, those are really important for how applications talk to each other. A service provides a stable endpoint for a set of pods. So even if the individual pods are changing or being replaced, the service IP address and DNS name stay the same.
So it's like a phone number that always connects you to the right person, even if they change their phone.
Exactly. And there are different types of services like cluster IP, node port, load balancer, and ingress. These offer different ways to expose your applications, either within the cluster or to the outside world. And then you have things like config maps and secrets, which are used for managing configuration data and sensitive information like passwords.
So it's really like a whole ecosystem of objects that work together to make sure your application runs smoothly.
Exactly. It's all about providing the tools you need to manage complex applications at scale.
Okay, so we've covered a lot of ground. What are the key benefits of using Kubernetes? Why is it such a big deal?
So we've touched on some of them already, but I think it's worth summarizing the key benefits. First, you have automated scaling. Kubernetes can automatically scale your application up or down based on demand, ensuring that you have enough resources to handle traffic spikes without overspending on idle resources.
So it's like the body adjusting its heart rate and breathing during exercise.
Exactly. Then you have self-healing. If a container crashes or a node fails, Kubernetes will automatically restart the container or replace the node, ensuring that your application stays up and running.
Like the body healing itself from injuries.
Right. Then there's load balancing. Kubernetes can automatically distribute traffic across multiple instances of your application, ensuring that no single instance gets overloaded.
So it's like the brain distributing tasks efficiently across the body.
Exactly. And then you have portability. Kubernetes can run on any cloud provider or even on your own hardware, making it very flexible. And it enables zero downtime deployments. You can update your application without any interruption to your users.
So it's like an ecosystem evolving gradually without any sudden disruptions.
That's a great analogy. And finally, Kubernetes supports multi-cloud deployments, so you're not locked into any one vendor.
So it's really like the ultimate platform for running modern applications.
It is. It gives you all the tools you need to manage complexity, to scale your applications, and to keep them running smoothly.
Okay, so for someone listening who's now really intrigued and wants to start learning more about Kubernetes, where would you recommend they start?
So the first thing you'll want to do is get familiar with the command line tool for Kubernetes. It's called kubectl. It's the primary way that you interact with Kubernetes clusters.
So it's like the keyboard and mouse for Kubernetes.
Yeah, exactly. It's how you tell Kubernetes what you want it to do. And there are some great resources for learning kubectl. The Kubernetes documentation has a really good tutorial, and there are lots of other resources online.
And what about actually running Kubernetes? Where can people get their hands dirty and start experimenting?
So for local development, there are a couple of really good options. There's Minikube, which is a tool that lets you run a single node Kubernetes cluster right on your own computer.
So it's like having a little mini Kubernetes playground on your laptop.
Exactly. And it's a great way to learn the basics and experiment with different Kubernetes features without having to worry about setting up a whole cluster. And then there's Docker Desktop, which also has built-in support for Kubernetes.
So if you're already using Docker, you can just spin up a Kubernetes cluster right there in Docker Desktop.
Yeah, it's super convenient. And then, when you're ready to move to a real production environment, the major cloud providers all offer managed Kubernetes services. You have EKS on Amazon Web Services, GKE on Google Cloud, AKS on Azure, and these services make it really easy to deploy and manage Kubernetes clusters.
Because you don't have to worry about all the underlying infrastructure.
Exactly. They take care of all that for you, so you can just focus on deploying your applications. And then, if you're more of a DIYer and want to set up your own Kubernetes cluster from scratch, there's a tool called kubedem that can help you do that.
Are there any other tools or resources that you would recommend for people who are getting started with Kubernetes?
Yeah, there are a ton of great tools out there. One that I really like is Lens. It's an IDE for Kubernetes. It gives you a really nice visual interface for managing your clusters, and it has a lot of great features.
So it's like a more user-friendly way to interact with Kubernetes?
Yeah, exactly. And there's Monocle, which is a tool for working with YAML files. YAML is the language that Kubernetes uses for configuration, and Monocle can help you write and validate your YAML files.
So it's got spell checker for Kubernetes configuration.
Yeah, kinda. And then there's Kubescape, which is a security tool for Kubernetes. It can help you identify security vulnerabilities in your cluster and your applications. And dtree is another helpful tool for validating YAML files, catching those pesky configuration errors before they cause problems.
And for those who are really serious about Kubernetes and want to take their skills to the next level, are there any certifications available?
Yeah, the Cloud Native Computing Foundation, CNCF, offers a couple of really good certifications. There's the Certified Kubernetes Application Developer, CKAD, and the Certified Kubernetes Administrator, CKA. These certifications are well respected in the industry, and they can really help you stand out from the crowd.
So if you're looking for a job in the Kubernetes world, those certifications can be a real asset.
Absolutely. They show potential employers that you have the skills and knowledge to work with Kubernetes effectively. And we'll make sure to include links to all these resources in the show notes.
Awesome. Well, this has been a really fantastic deep dive into Kubernetes. We've covered a lot of ground, from the basics of what Kubernetes is to the benefits of using it, the architecture, the key components, and even some resources for getting started.
Yeah, it's been a great overview, and hopefully listeners now have a much better understanding of what Kubernetes is, why it's so important, and how it works.
And I think that human body analogy is really going to stick with me. It's a really clever way to visualize how all these different components work together.
Yeah, I agree. It's a great way to make a complex topic more approachable. And, it makes you think about how these principles of automation, orchestration, and self-healing that we see in Kubernetes could be applied to other complex systems.
Like, could we use these same principles to manage traffic in a city or to optimize energy consumption in a building?
Exactly. I think there's a lot of potential there, and I think it's something that people are going to be exploring more and more in the years to come.
Well, that's a really fascinating thought to leave our listeners with. So as you go about your day today, think about all the applications you use, all the websites you visit, and remember that behind the scenes, there's a good chance that Kubernetes is working hard to keep everything running smoothly.
It's the invisible hand that's powering so much of the modern web. And as we become more reliant on these complex systems, understanding how they work is only going to become more important.
Thanks for listening to The Deep Dive. We'll see you next time.
See you then.